Dijkstras' algorithm finds the minimum distance from a starting point to anywhere in the network, and it uses temporary and permanent labels. For this one, I'm going to go from A to J. So I'll start off at A. I haven't got anywhere, so it gets a permanent label saying I haven't gotten anywhere. Now I'll look from A and I see, or I'll look for the shortest distance out of A. So going to 9, going to B is 9, and I've come from A. Going to C is 7.5, and I've come from A. Going to D is 10.5, and I've come from A. That's all the ones coming out of where I've just done a permanent label. The shortest distance of any on the network is 7.5, which is C, sorry. There. Now then, look from C and update any of your minimum distances that are directly connected. 7.5 plus 4.5 is 12, and 12 has come from C. 7.5 plus 6 is 13.5, and that's come from C. The letters help you find the path back. 7.5 plus 6 is also 13.5, and that's come from C. So I've updated anywhere coming out of my last permanent label. Now then, look for the smallest number of any of the ones you've got. So that's 9. And then do the same, update anything connected to where you've just done a permanent label. 9 plus 3 is 12, so 12 is coming from B. 9 plus 2.5 is 11.5, so it's shorter, so 11.5 is coming from B. Them are the only ones coming from 9. So now I need to look at the shortest distance of any of them, so that's 10.5. So 10.5 is coming from D. So 10.5 plus 1.5 is 12, coming from D. 10.5 plus 7.5 is 18, coming from D. And them are the shortest distances. So now we'll look for the smallest number. So 11.5 is my smallest number. So going from E, 11.5 plus 10.5 is bigger than 12, so don't change it. 11.5 plus 3 is 14.5, it's bigger than 13.5, so don't change it. There's none others connected to E that don't have a permanent label. So now just look for your smallest number. Your next smallest number is 12. There are 2 of them. It doesn't matter which one you go for. I always go for the one on the left. There we go. So I've put my permanent label on that 12. So from here, 12 plus 4 is 16.5. Don't change it. 12 plus 3 is 15. So do change it. So 15 coming from F. There's nowhere else from F without a permanent label. So then look for your smallest number, which is 12. Put a box around 12. Look from 12 now for anywhere you can update. 12 plus 9 is 21. So that's 21 coming from G. There's no others you can update. So look for your smallest number. Your smallest number is 13.5. Now try and update from there. So 13.5 plus 6 is 19.5. So I've got 19.5 coming from H. There's nowhere else I can update. So look for my smallest number. 15 is my smallest number. Update where you can. So 15 plus 3 is 18. So 18 coming from I. There's nowhere else now, so I just boxed the 18 at the end. Everywhere's boxed, so I've got permanent labels everywhere. So I know the minimum distances from A to anywhere in the network, but also I can find the route for getting there. So this is your part 1. Part 2 wants the route. So I was going from A to J. So starting at J, it tells you I come from I. Going to I, it tells you I came from F. Going from F, it tells you I came from D. Going from D, it tells you I come from A. So my route is A to D to F to I to J. On the exam paper, obviously you put that somewhere where it's easily seen on the next page. But I haven't got a lot of room on the paper, so I've just had to stick it at the bottom. Anywhere it's done, any writing, any of these permanent labels or temporary labels, if you do them in the margin or at the top, then it doesn't get scanned and it won't get seen and you won't get the marks for it. Make sure that if you cross out, but you do just cross out, that you don't scribble it out. They've got to see the numbers. Okay, well done. See you later.